All right, thank you very much. I am really excited to be here today to talk to you about nurturing the next generation of open source contributors. And by the next generation, of course, I mean students. So here is a super embarrassing photo of me when I was a student, so a bit younger than the students we're going to be talking about today. But my name is Tyler Menezes. I am the CEO of the nonprofit. We're based in the US, but we work all over the world. We're called CodeDay. And there's a couple things that I'm going to talk to you about today that you can expect to take away from this talk. So the first thing I'm going to talk about is why should students care about open source software, and why should maintainers of open source software care about working with students? The second thing that I'm going to talk to you today about is what problems do students face when they try to contribute to open source software. We're going to just go through the top 3 most common problems that students face when they start contributing. And lastly, I want to talk about some things that maintainers can all do to make their software projects easier for students to get involved in. So let's start with that first thing. Why should students care about open source software, and why should maintainers care about working with students? And I'm going to answer that in just a second, but I'm going to start out with a story. So CodeDay, the nonprofit that I work for, we started out actually doing these sort of in-person hackathon events for secondary school students, high school students in the US. We do these events. We bring together a bunch of students who think that they don't like computer science. And we get them together for a weekend, and we help them make cool stuff. And we have a big focus, like I said, on people who normally would not ever go to something like this, so we don't call them hackathons. It's where the name CodeDay came from originally. And one of the things that has made these events really, really interesting and successful is creativity. Students love having the opportunity to create something and to just bring their passion and excitement and come up with something totally new and novel that we've never seen before. So this is actually an example of a project. This was made by someone who had never coded before. The code, I should say, was done by someone who had never coded before. The art was done by someone who had never done art before. They sort of switched roles. The artist did all the code, and the coder did all the art. And this is a game that they made in a weekend where your words are your weapons, and you use your words to build up your allies and tear down your enemies. Here's another example of a super creative project that someone made at a CodeDay that had never done this before. This is a project someone made called Pocket Frog. And it's a little, if anyone remembers Tamagotchis, if that was a thing here, it's a little electronics thing, and it monitors, in this case, it monitors your environment and uses the, the temperature and humidity and things like that to basically keep your frog healthy. These are super creative projects, and it's super fun. And this creativity, the opportunity to express creativity has been something that's made these events super popular among students. They love creativity. We've had 83,000 students who've gone to events all over the world in person. Like we've gotten them out of their bedrooms. They're here. They're building cool stuff. We've been doing this for about 15 years now, so it's been quite a while. And a few years ago now, I guess, around 2020, we started to hear from students that they wanted the next step. They love the creativity, they love the option to do something creative, but they want to do something that makes a real impact. They want to do something that really changes the world around them, that shows that they have agency and that they can do real important work. And so we were starting to think, well, what are some ways that we could get students working on projects that actually matter to them? CodeDay, I used to work in the startup industry. I am very much still a developer at heart. We have a ton of open source software that we've written in-house that powers all of our events. We do a lot of these events. We have a very small budget. And the reason we're able to do that is entirely automation software, stuff that's powering a lot of stuff. So we have this whole stack of software. And students have been contributing to this for a while. And that's something that they've been making an impact on. And then we also had some cool examples where alumni of our program who had contributed to our open source software were going out and doing more open source software. So this is an example of a now archived GitHub repository by one of our students named TJ. And they had, while they were starting in middle school in the US, like 7th or 8th grade, had started contributing to our open source software. And by the time they had graduated secondary school, high school in the US. They had built this open source front end for MakerBot 3D printers that was so popular that they were offered a job straight out of high school. They never had to go to college. Like they graduated and 18 years old, they moved across the country to New York to start their first software developer job. So open source software for us has been really cool and an amazing opportunity for students. And we started to think, there are all these great projects out there that need help, that need more students. We see initiatives like Hacktoberfest, which is a great way to get more people involved. We see things like projects making a lot of effort to tag things as good first issues. There are lots of projects out there that are looking for things. And so we have two things. We have students who have a lot of creativity and a lot of passion, and they want something to work on that really makes a difference in the world. And we have maintainers who have this software that, for everyone who's seen the XKCD comic, the software is thanklessly maintained, but underpins all of our modern technology. And we want more people to help us maintain it. We want more people who are creative, who are going to be passionate contributors. And so we saw these two things, and we were thinking, well, maybe this is just a matchmaking problem. Maybe we just need to match students up with open source software. And so that's what we started to do back in 2020. And we quickly realized that students needed a little bit more support than that. So we've now sort of built out this whole model here where we also connect students up with an industry mentor who knows nothing about open source or their specific open source project, but it helps them think like a developer and say, yeah, I have no idea what's going on either, but here's how I would go about this. We'll talk about the importance of that in a couple minutes. And we match them up with sort of TAs, just peer students who maybe are a little bit more approachable because they're a little bit scared to go out and talk to these really important people who are maintaining this software. And of course, a lot of open source projects have SMEs, have subject matter expert mentors who are able to help with their specific software too. So this is a whole ecosystem of people helping people become new contributors that we've built up. And so going back to that question that I started this section with, what do students and maintainers get out of this? Well, students are getting the ability to make an impact. And for them, that is so important. That is so empowering. It's so exciting. They spent their entire year, their 18 years of their life basically learning. And now it's the opportunity for them to show that they can do something. And for maintainers, they're getting the opportunity to work with new, creative, and passionate contributors who bring an entirely new perspective and are very excited to do something like this. So that's why we should care. But I want to talk about the biggest barriers now that are preventing most students from contributing to open source software. And I'm going to talk here mostly about college, university age students, because that is at the age where most of our students are contributing to open source software. So the first of the barriers that I want to talk about is what I call the expert fallacy. And I call it a fallacy because a lot of students think of software engineers as experts, as people who truly know everything that there is to know about software development. And I think a lot of the times this is subconscious. Maybe they wouldn't say this out loud, but they truly do believe that when they graduate with their degree, they're expected to know everything there is to know about software development, which for me is comical. And because of that, they don't really learn how to work independently. They're expecting to already know the answers to things. So the reason for this is, to me, pretty obvious. Students spend, as I said, somewhere around 18 years of their life in this school environment. And what do you do if you're in school? Well, you study for a test, and then you study for the next test, and then you study for the next test, and then you study for the next test, and so on and so forth. And that's all you do for most of your life. There's homework, maybe there's some group work projects and things like that, but you're always really fundamentally, you're preparing for the final for your class or some sort of standardized tests. You're always preparing for the next test. And what happens if you don't know the answer to something on the test? It means that you have failed at least that specific question, because you are supposed to know the answer to every question that you come up against when you're a student. For me as a developer, when I when I see something and I think I don't know what to do, what's the first thing that comes to my mind? A lot of people here are probably familiar with this website, right? Stack Overflow. There's Google. There's ChatGPT. There's so many great resources out there when I don't know what to do for me to learn how to do it. But for a lot of students where it's their first time contributing to something real, something that matters, when they come up against something they don't know what to do, they just panic. They throw up their hands and they feel like they failed. And they have a tendency to do a lot of sort of very idiosyncratic behaviors. They will sometimes just like decide to give up or decide that they're not going to do anything because they don't know where to start. Some people, I have seen students just do what they know best, which is studying. And I've seen students go out and get the method signatures for like every function in a library and just start taking notes on method signatures. There's a lot of silly things that students do that are not necessarily helpful to them because they feel like they don't know how to approach a problem that they don't know how to solve already. So one of the things that we can do for students is help them start to break out of this cycle. And I'll talk about how to do that, but we really need them to realize that it's not just about a test, that this isn't a test, and that as software developers, as people who are working on these projects, every single day we are solving new problems that no one has faced before. We are learning new things. No one truly knows everything in software development, and that's part of what makes this job so great, right? We do get to learn every single day. We need them to think about when they see something and they say, I don't know what to do, we want them to think, I don't know what to do, but I can learn. So that's the first big barrier that's preventing a lot of students from contributing to open source software, is this idea of, I don't know what to do, so I'm going to just throw my hands up, give up, panic. The second one is what I call the software development process. So this is something that all of us as developers, I think, inherently do some version of, and I'll talk about what it is, but there's some process that we usually follow when we do come up against a problem that we don't know how to solve. And no one teaches this. I have seen one college that we work with that actually explicitly states this in a class: what should you do when you come across a problem that you don't know how to solve already? So we actually talked to a lot of our mentors. We have over 1,000 mentors who are professional industry software developers. I'm a software developer myself. We talked to a bunch of people and we tried to figure out what is it that software developers do. And there's a process that most of us are following. So first of all, we need to figure out what the problem is, right? Our code's not working. Well, what does that mean? What's not working? What is the error message we're getting? What are we expecting to happen that's not happening? What are the different parts of the code base that might be involved in this? Which specific line of code or which method or interaction between different parts of the code, what is causing the problem? We need to figure that out first. We need to be able to identify what is happening. And doing that is not a skill that's taught. Once we know what the problem is, we need to do online research or talk to more experienced peers or something else. We need to figure out, has anyone else seen this before? And is there something that we can do to very easily solve this? And again, that goes back to that previous point. A lot of students are just afraid to ask for help. We experiment. We try things, right? Hopefully, for most good, well-run software, this is not going to cause any catastrophic failures for anyone. There should be a good development environment. And so it shouldn't really be that scary to just try something and see what happens. But again, it's not something that most students are familiar with because you're just supposed to know the answer to something. As software developers, we sort of iteratively come up with a bunch of proposed solutions, things that we think that might work, and we try them out. We come up with our favorite solution, the thing that we think best solves the problem. And then hopefully we verify the problem is solved. Maybe our project has automated testing, and we can very rigorously test that this actually did solve the problem. For a lot of us, it just means we're going to do a bunch of edge cases and see if it works well in those edge cases. And then this is the one that a lot of people don't do, which is document the solution in some way. So that's the process that we've found that most software developers are doing. But again, Very few students are explicitly taught this. It's not really like a slide that ever comes up in their education, and it's not something that they have a lot of practice doing. It's not something that they are getting a lot of practice in their sort of traditional book-based education learning how to do this. And so if they're contributing to an open source project, it might be the first time that they're ever thinking through these steps. The last of the three really big issues that students face is just the difficulty in navigating a real code base, especially for someone who is a brand new developer. So as professionals, as people who've worked in the industry for a while, professionals have built up decades worth of just what I call context, right? There's a lot of information that we have as professionals that when we see something, we can sort of recognize a pattern, or maybe we don't know, what a specific method does, but we recognize all the methods around it, and we can kind of guess at what that does, right? There's a lot of context that we have that students don't have. And so when you look at something like this, this is a diagram I found on Wikipedia. This is the simplified Linux kernel diagram. Yeah, again, simplified. This looks really complicated, but I can look at this for a couple minutes and see, like, as someone who's used Linux for a while, and as someone who has been a developer for a while, I can sort of think about, I kind of know what a block device is, right? Maybe I don't know rigorously what a block device does, but I generally have an idea of what I think it is. And there's a cache in there. I understand what a cache is, and I definitely know what a swap file is, right? And so I can sort of see how all of these pieces fit together. And when there's a piece in this diagram that I don't know, I can figure out from context what it's doing. But for new developers, they don't have any of that information. They don't have any of that context, or they have very little of it, at least, because they haven't seen that much, right? They've just done the formal education, and that just covers a small sliver of real software development. They haven't seen that much. And so when they look at a diagram like this, it takes them a lot more effort to figure out what's going on. And the reason why I say this is one of the biggest problems for new developers is this. What's the first step on that software development process? It's identifying and defining the problem. One of the biggest problems that we find for new developers is just figuring out where in this 10,000 plus lines of code, where is the problem happening? Figuring that out is very difficult for them, and understanding just generally where to start looking is very difficult for them. So those were the three biggest problems that students are facing, but I wanted to talk now about how can maintainers help make it easier for students. So first thing is mentorship. This underpins a lot of the stuff that we talked in that last slide. Just proactively offering help addresses a lot of those biggest barriers. If you are offering help to students in some way, to help them become new contributors, just talking with them even about how difficult it is getting spun up on a new code base is really valuable for them. Mentorship does not have to mean subject matter expert, deep technical mentorship. A lot of the times it just means being a more experienced friend and saying, hey, I was in this position too, and yeah, it is kind of scary, but we'll figure it out, and in a couple weeks, you'll be up and running on this code base. And yeah, it's totally normal sometimes, for example, to spend, a week trying to get your development environment set up, and, maybe you can help document it for us for the next time. The second thing mentors can do is just have a really good contributing file, resources, coding conventions, styles, code of conduct, anything anyone needs to know to get started. Making people dig for that kind of sucks. And then also, if students are contributing to your project and they do open a pull request, it really is difficult for them then when their pull request is not merged because of some sort of silly mistake that they've made, and then they need to come back a couple weeks later once it's reviewed to go in and fix that. And again, remember, a lot of students are still in this test mentality, so they are thinking in terms of studying for a test, and they're supposed to get a perfect score, and hey, I failed, my pull request was not merged. It can just be very difficult. So making it really upfront about what you're expecting from them is really valuable. The second thing is having a good dev environment. Talking about how to get it running. A lot of developers also are using Linux or Mac, but from my experience, at least in the United States, a lot of students are still using Windows, which unfortunately does cause a lot of software to not work quite the right way. And for students who are new to contributing to open source projects, that can be sort of a challenge. So there's a lot of things we can do. We can create some sort of Docker container that runs really well. If you have it building on Linux or Mac, I just put in a reference in my contributing file, just saying if you're using Windows, try Windows Subsystem for Linux. That solves a lot of problems. If you're doing something web-based, there's a lot of web-based IDEs like Replit or code spaces that can allow you to get a dev environment running literally at the click of a button. But anything you can do to make it faster for people to get up and running as a maintainer is going to save them a lot of work. And honestly, it's going to save all of us a bunch of work. Next one is CI with linting and tests. Again, this goes back to it kind of is just an awful experience if you spend 2 weeks working on your first pull request and you submit it, and we're all busy, and no one reviews your pull request for a couple of weeks, and then finally someone reviews your pull request and, oh, you accidentally used tabs instead of spaces, which is a mistake that all of us have made at some point earlier on in our career, and we probably don't make it anymore, but it's a really small mistake. That's a super common one. Windows style, like /r/n, new lines instead of /n. That's another really common one. If you have linting and you have tests that catch those sort of things early, it just prevents so many problems for students. And figuring that out the moment that they open their pull request, rather than 4 weeks down the road when they're now studying for finals, means they're much more likely to actually successfully get their pull request merged. And what we found is if students get a pull request merged, they're way, way, way more likely to continue to contribute and become regular contributors to a project. Moving on to some things that you probably are less likely to have in your projects already. Architecture.md, this is one of those sort of systems diagrams, like with the Linux kernel simplified system diagram. Most projects are not as complicated as the Linux kernel, and even if students don't always know exactly what they need to put in their architecture file, exactly how to read their architecture file, just having some sort of diagram that generally shows how do the pieces of your project fit together. How does the information flow from input to output? What in general is happening behind the scenes can be really helpful. And again, this is not just helpful to new contributors. This is really helpful for existing contributors too. This really is something that is helpful for everyone. And actually, I do know a lot of the Eclipse Foundation projects have, if not literally an architecture.md file, they do have some sort of architecture diagram somewhere, which is great, and it's a super great resource for students. So I'd encourage all maintainers to try to put something together like this. And if you search for architecture MD online, there's a couple great blog posts that people have put together on how to put together a good architecture file. Last one is good first issue. A lot of people know about good first issues, right? It's a great way to get new contributors. It's a great way to show them what they can do to get started on your project. Here's the question for you: what actually is a good first issue? So we've had students solve a lot of issues in our projects, and we've sort of looked at what has worked and what hasn't, and we've come up with a couple criteria that might help you to decide if something is a good first issue. So the first one is it self-contained? Is it something that's solved in one place? This is one of the most useful things for a good first issue. This is the only real technical criteria that we found. If you have to understand how 5 different pieces fit together to understand the problem, it's not a good first issue. Now, not all the time do we as project maintainers know if something is going to be self-contained. We make our best guess. Even as people who are new to a project, our team will go in sometimes and we'll look at issues and we'll just make our best guess. And most of the time we're right. Is it clear? Is there enough detail that you don't need to ask the maintainers for more clarification? Because again, that cuts in on time. If someone is waiting for you to respond to them, they're not working on contributing to your project. This is a big one. Is it decided? We have had people sometimes who have tagged things as good first issues that actually have some sort of inherent design decision that needs to be made. And those design decisions take like weeks of discussion, and someone really has to be driving that decision to be made. And so your good first issue, you want to be something that is not requiring a maintainer discussion in order for the students to move forward. And then lastly, recent, a lot of times issues just inadvertently get solved. And so quite frequently we found that people are having issues that are not actually issues anymore. So if you want your one picture, these are the things that are going to be the most helpful for getting students involved in a new project. Mentorship, if you can offer it. Contributing file, a dev environment, CI with linting and tests, architecture file, and some good first issues that are self-contained, clear, decided, and recent. OK, so how well has this worked for us? So I want to give you a couple examples here. There's a few ways to answer the question of how well has it worked, but my favorite is just what cool stuff have students made. So here's two examples. Some students added to the Cesium open source visualization platform the ability to visualize one of the standard formats for self-driving cars that's used. So basically the LiDAR sensors on self-driving cars, now people who are working on self-driving cars can visualize this really easily in this open source project, which is super cool. Another really cool one that we've had, this is also DataViz. I don't know why, it's just the DataViz projects, I guess, make better screenshots. There's a really cool open source project called Hubble GL. It was originally made by Uber Elevate, which was Uber's now defunct flying car division. But it's a really cool open source project for visualizing airspace. And we had some students who built the ability to export an MP4 like video file directly from this open source project. So you, rather than just like trying to screen record your web browser, which wasn't working well, you can just pick your start time, pick your end time, and just export a movie showing what's going on. So those are a couple of cool examples. We've had about I think at this point, like well over 1,000 contributions to open source software. We have them all on our website, so if people are interested, you can take a look there. You can look at this from an education perspective. So I talked about that software development process. Here's a screenshot from a paper that we published a couple years ago showing it doesn't matter all the specific details, but basically we asked mentors to rate the students. How good are they at this software development process? How good are they at working independently? And on the up and down axis, you have their average rating from 0% successful to 100% they thought they were doing really well. And then on the left and right axis, you have the time. And it was super interesting when we collected this data because we saw that the average rating started out not that great. It was like less than 60% of mentors thought that the students were performing at even an intern level in the software development process and the ability to work independently in software development. And then it actually went down for the first 2 weeks. So the students were doing worse. They were really, really, really struggling. But what we saw was that at some point for all of these students, it actually clicked. They really understood, oh, really, truly, no one does know the answer. And they started to develop their own system for working through problems. And so we saw that then for the rest of the program, the results actually improved quite dramatically. And the students ended up at about 80% positive ratings from their mentor. And these were students who had never done any work outside of schoolwork before. So the students gain a lot out of it from the education perspective too. It's not just that we as open source folks, we're getting a lot out of it. The students are getting a lot out of it for education as well. I didn't put a slide on this, but in the US at least, the cost of education is extremely high, as people probably have heard about us. A lot of our students in particular come from low-income backgrounds, and they tend to go to schools that are not very expensive, but also don't have great brand recognition. They're not like MIT or Stanford or someone you've heard of. It's like Green River College, which if you have heard of Green River, Washington, it's because we had a serial killer there in the 80s. It's not very well known. And so a lot of students from these schools don't have job experience to put on their resumes because no one's hiring them as interns. And then no one's hiring them as graduates because they don't have internships, and still no one has heard of their school. one of the advantages of this too is that the students who contribute to open source are getting something out of it in terms of they're much more likely to be employed in the software industry. And by the way, most of our students do keep contributing to open source. So the open source is getting that out of it too. There are a bunch of papers that we've published about this showing how well this works. If you're interested, if you search for my name, you can find them. There's a lot more details. I don't even know if you can read those citations, but you can search for my name to find them. So last thing I want to leave you with is this. We'd love to work with folks to help more students. We had that whole list of things. We're happy to help open source projects do a lot of this stuff. We are happy to provide mentors. We are happy to work with you on your contributing files, on getting the dev environment working better. We'll actually, as students are working through things, we'll have them open pull requests to fix problems in your documentation. And we're even happy to help work with you on finding good first issues. So if you are an open source maintainer, even if it's just a project with 100 users, we'd love to work with you. And if you're interested in mentoring a group of students, there's the link for that too. I put all my contact info. I think we have like a minute for questions. We'd love to have your help in getting more students into open source and helping make a difference. So thank you very much. Cool. And I think they're coming around with the microphones.
Hi, Tyler. Thank you for your very important work. Nice to see you again.
Thank you.
Do you have any numbers in mind about how many students actually then stay in the same project where they started? Like, I mean, because I can assume there's some sort of fluctuation. And me, as a maintainer, the first thing I ask myself is like, I do want to help them, but if I invest my time, is this guy going to be loyal to me and stay here and help me?
Yeah, so how many people stay in the same project? That's a great question. Right now, it's around 43%, I think. So a little bit less than half of the students will open a second pull request in the same project. Most of the people who open a second pull request will continue to contribute to the project over time. So it's less than half. We're working on increasing that. There's a couple of new resources we're adding to our program specifically to try to help get more students to stick around, just basically longer-term mentorship to help them make that second pull request. But yeah, so right now, a little bit less than half. We're hoping to get it up to about 60% soon.
That would be awesome. Thank you.
Thank you. Any other questions? Awesome. Well, thank you all for coming. I really appreciate it, and I hope you have a great rest of your last day.